Hi, welcome to Team Covid Archi's 2021 IBDC project submission. We have studied and designed a mixed-use sustainable development that aims to rejuvenate the site at Jalan Bukit. The overview of our content is as follows. The site is surrounded by low to mid-rise buildings that do not disturb the prevailing northeast and south winds. This provides the site with good natural ventilation that we wanted to take advantage of. The Bukit Timah Nature Reserve, located near the site, not only provides exceptional views but also invites more winds to the site. The site has favorable access points for both vehicles and pedestrians. The 4 routes surrounding the site has fast traffic. We have provided a total of 5 entry points based on our analysis of pedestrian circulation with regards of the existing infrastructures. Given Singapore's location on the equator, it faces a tropical rainforest climate as reflected in the Köppen climate zone map. The site faces uniform temperature and pressure with high humidity and rainfall throughout the year. The amount of sun that the site experiences is also relatively similar throughout, with 8 to 9 hours during the dry season and 4 to 5 hours during the wet seasons. We leverage on the site analysis workflow to design a comfortable and suitable building on the site. With the use of softwares such as Grasshopper, we were able to analyze different environmental factors such as the temperature, humidity, wind speed, wind direction, and solar radiation. We also did a secondary research using Andrew Marsh and Google to obtain and gain even more understanding of the site environment. For our massing, we started out with a block that outlined the perimeter of our site. For our commercial development, we determined the places where we wanted to place our feature space, which was the public garden area, with reference to the placemaking. We wanted these green spaces to be an extension of the nearby Bukit Timah Reserve. We subtracted volumes of pure commercial mass according to vantage points of both vehicular and pedestrian circulations. The significant voids, which is characterized by the retention pond located in the middle of our building and is linked with the man-made river that penetrates our commercial massing, was placed to draw people into our building and provide them with an exciting and open space to walk around, mingle, and shop. We have placed the residential blocks closer to the Bukit Timah Reserve to take advantage of the views and prevailing winds. The 4 blocks have a symmetrical stepping formation and are connected with communal sky garden for residents to enjoy and use. The shorter end of the massing is facing towards the east and west respectively to reduce heat gain and solar glaring into the residential block. With the shorter end also facing the highway, it reduces the number of units affected by the noise and dust. The longer sides are open towards the prevailing wind direction on the north and south.
For green spaces, they are seamlessly integrated into the design of our building, where pedestrians may take a stroll or rest in these areas. Green spaces support biodiversity conservation by cooling, noise reduction, and air filtration of pollutants. Implementing green spaces will help shade common spaces, which is crucial in warmer countries like Singapore. Natural ventilation is important in improving indoor thermal comfort and air quality, ensuring that the air is not stagnant but instead well regulated. Energy-efficient products are considered in our building. For instance, the escalators used in our building will slow down when it is not operating during peak hours. This helps to minimize the daily expenditure. Additionally, natural ventilation reduces a building's cooling energy consumption, which is often very high in Singapore due to its warmth and humidity. Developing a connection between the central water catchment and our site is essential. With plans on having underground pipings, the river and central water catchment works hand in hand. During monsoon seasons, if the rainwater exceeds the threshold that the river can contain, it will then be stored in storage tanks which will be used for commercial and residential purposes. During the drier seasons, the river is able to double up as a dry landscape, where the water level is low. This is an opportunistic idea that the team has adapted from the Bishan Ang Mo Kio Park in Singapore. When the water levels are low, kids are able to play around the waterway in the park. If needed, the water from the central water catchment may also flow into our development through the retention pond and then the river. Implementing subsoil drainage through previously perforated pipes in Bukit Timah Nature Reserve allows the additional water to be channeled towards the main pipings. Here is the location of urban farming and retention pond for reference later. Next is a schematic section facing urban farming. At commercial level, stormwater from the urban farming and green spaces passes through the biofilter and is collected at the storage tank. The filtered water collected in the storage tank is then directed to the pump tank. This allows the water to be pumped to various parts of the commercial for usage such as equipment washing. At residential level, the retention pond is utilised. The excess stormwater collected from the river will be filtered and pumped to the units through the retention pond. The water tank located at the roof of the units acts as a storage point, which readily provides water for filtration. From the water tank, water passes through the ultraviolet water filter, inactivating airborne pathogens and microorganisms such as mold, bacteria, and viruses. After filtration system, the water is then distributed to the units for usage such as flushing of toilets or cleaning of corridors.
We have implemented technological features to support the sustainability of our development. Underfloor cooling below the floor slabs of each story provides a comfortable temperature. This is a system that uses less energy than air conditioning, as seen the cool water flows through these pipes before going back to the chiller on the roof. The solar panels are placed on the roof of the residential and commercial. These two types of photovoltaic panels used are monocrystalline and polycrystalline solar panels. Polycrystalline solar panels produce less energy but are cheaper and eco-friendlier compared to the alternative. These panels use the sun to provide electrical energy, saving on the cost of electricity. The building automation system is integrated into the development. This reduces manpower usage and allows for different systems within the building to be used over a longer period of time. Working together with them are the sensors placed all over the development, which helps save energy. This is the flow of information between the sensor and the system.
Onto circular design, our building leverages on the 5 aspects of circular design. Firstly, for high-grade products with high recycled content, the use of concrete for PPVC, wood for MET construction, glass for curtain window, and metal in this building. Considerations were made to prolong the lifespan of the building, contributing to the waste prevention. It also helps to create the demand for recycled materials, increases the quality of recycling. Secondly, for the design for this assembly, materials are used in the development that can be reused. For example, PVC modules can be separated, MET wood can be detached, which all can be reused, contributing again to the waste prevention. Thirdly, the material passport, preventing the choice of material usage and included the logistic and data that analyze the characteristics of materials and components. We also have factored the source of separations of end life of these materials. Overall, this helps to increase the quality of recycling and circular design. Next, for the extension of construction of service life, considerations were made to ensure quality of life of material and design. This enables renovation, improved maintenance, upgrading, and repair works of the future. Lastly, will be the selective demolition. Construction method of design using the components fabrication of different materials are considered to allow selective demolition of hazardous materials and also increase the source of separations into high value and into pure material fractions.
We have planned for each PPVC to be done floor by floor. Our considerations maximized productivity of construction and allowed us to minimize the chances of revokes. The constructed PPVC modules will be stored at a warehouse until it is needed. It will then be transported by a truck with the appropriate width of at least 3.4 meters and height of around 4.5 meters to be able to safely transport the modules from the factory to the site.
There are 4 main stages of construction planning, the first being architectural design, followed by surveying of site, transportation, and finally construction. In construction planning, we have different sections of our building. We have a precast central river located in the heart of our commercial, then the east wing in purple, followed by the west wing in pink. Finally, we have in place our residential PPVC denoted by color green. This is an overall look of different sections of the building. In order to construct this building, we have 2 mobile crawler cranes with a maximum hoist height of 148 meter and maximum radius of 103 meters. Those are the two crane positions on the construction site. As you can see, the crane's radius can sufficiently reach the different sections of the building.
For IDD, the digital design is to achieve a design objective of rejuvenating of the site of Jalan Anak Bukit. We design a collaborative and coordinated mixed-use development which comprised of an open commercial area, retention pond, man-made rivers, residential blocks, and abundance of green space. With the use of digital software, we were able to analyze the environmental consideration and leverage on the result to design a sustainable and comfortable building. For digital fabrication, the use of DFMA technologies improve the workmanship and the quality of the construction. It also allows for us to plan more precise and in-sequence work. It also provides a better logistic and management coordination with increased workplace safety. Overall, the choices of using PPVC for our residential building improve the efficiency and the quality of the spaces. For the use of design for manufacturing and assembly, our group utilizes PPVC module for our residential block. We have a total of 11 PPVC modules that are built and delivered to the site. These modules are fitted with MEP tracks and ceiling modules. We have also included prefabricated bathroom units to increase the efficiency of our construction period. The underfloor cooling system is also integrated within the modules to provide the residents with a comfortable atmosphere inside their houses. There are 3 types of PPVC modules available. First up would be the duplex. Due to the higher demand for privacy living spaces, it provides the luxury of 2 bedrooms with separate balcony and a central living area. The second module would be the simplex, which is the modular basic apartment type which occupies 1 unit. Lastly would be the duplex plus, which has 5 rooms that allows for larger living space and a kitchen area.
There were various teamwork and learning hurdles faced by our team. The first was time management. We were struggling due to the close time frame of school and IBDC submissions. To resolve this, we crafted a project schedule that was separated into 4 phases in order to monitor our progress. We also scheduled online meetings weekly through Microsoft Teams and created a WhatsApp group to easily notify each other regarding any updates. Our second issue was the conflicting ideas and visions about our design. We had to be sensitive and listen well to each other while sharing our objective opinions. To further tackle this issue, we have split ourselves into 2 groups, architecture and civil engineering, with both groups having a team leader who decides on what to do. We also had to overcome the fact that we did not have much experience on designing on building of this scale and features. As a result, we had to read up on various case studies to learn more and familiarize ourselves with the project. Some of us also had to pick up new software skills that was not taught in our school curriculum, like Grasshopper, in order to do various environmental analysis. In conclusion, throughout the past few months of working on our project, our group learned to collaborate and manage our time better given the tight schedule that we had. We also improved and expanded our knowledge on sustainable features that is definitely relevant to both our studies and Singapore's current and future built environment. We learned to become objective and professional with each other through the allocation of work and respond to changes positively. It has been a great and informative journey, and we are glad to have shared our final project with you. Thank you for listening.